Okay. Yeah, so just by way of introduction, I study past climate change. So I'm a paleoclimate person, and I don't look at climate change as it happens over days or weeks or years, but rather as it happens over thousands of years. So when I think of Montana, my thinking often starts 15,000 years ago at the end of the last ice age. And for a lot of Montana, 15,000 years ago was the glaciers were receding and left a very barren landscape with no soil, no trees, no lakes, no wildlife. And so in my research, I try to understand how the present ecosystem evolved. So I look at a landscape and I think, well, what were the first colonizers after the last ice age? What were the first species that came in? And how sensitive were they to past climate change? What's been the role of fire in shaping ecosystems? And the information for my research questions come from lakes. Lakes are great repositories of environmental information. You know, everything that falls out of the air and lands on the surface of the lake can get buried in the mud. And so we go to lakes and we get vertical cores or tubes of sediment. And as you can imagine, the top layer of mud in those cores was laid down just recently, but we can go back layer by layer through the cores to the bottom, which was deposited when the lake first formed. So in Montana, lakes tend to have maybe 30 feet of mud. It's amazing. And those records, when we radiocarbon date them, will go back 15,000, sometimes older. We take those sediment cores back to the lab at MSU and we slice these vertical cores open, and even the sediments themselves tells us about past climate. The light layers are times when it was warmer and the dark layers are times when it was colder. And we take samples of mud from top to bottom that we treat with different chemical procedures to pull out what's in the mud. And then we look at those samples layer by layer through these cores to see what's there. So it takes a graduate student about 2 years to work through the analysis of a lake. And the things that we're looking at and that we specialize in is fossil pollen. Different plants produce different looking pollen. And when you know the pollen, you know what the vegetation was like. And when you know the vegetation, you know what the climate was like. But we also look for black particles of charcoal because those tell us about the occurrence of ancient fires. And honestly, in paleoclimate, you're looking for anything you can find in the mud because each discovery, whether it's a piece of bone or insect parts, tells you about the past environment. Now, when most of us think about climate change today, I think we think about these extreme weather events, these climate-driven weather events that are happening around the world, where, you know, a third of Pakistan is still underwater, and we've had these enormous floods and enormous fires. And climate scientists are getting better and better at determining what percentage of the severity of a particular event is related to climate change and what would have happened naturally just because of the variability in the climate system. So, for example, the floods in Germany, shown here, about 20% of their severity is attributed to climate change. In California, the area of the fires is probably twice as large as it would be because of climate change. And these storm events have a certain percentage of just being slower and more intense than would happen normally. And these are well described in international and national studies of past climate change. So the International Panel on Climate Change, the IPCC, just released its latest report talking about the impacts and the need to try to keep the global climate below 1.5 degrees centigrade, or about 3 degrees Fahrenheit, to avoid a lot of disasters around the world. The National Climate Assessment comes out every 4 years. The next assessment, the 5th assessment, will be released in the next few months. and it looks at the impacts in the US. But in Montana, we have particular things that we worry about that other parts of the world are not experiencing. For example, I just downloaded the drought monitor map for this past week. And you can see that there's parts of the country that are still experiencing exceptional drought and extreme drought, including about half of Montana is in some state of drought. And it's been that way for a while. It's long-term drought. It'll take a while to get out of it. And Zach, who's talking this afternoon, will tell you more about how these maps are developed and what's being done to better study drought. And as one of you mentioned, we also are very impacted by wildfires, not only fires that happen in Montana, but fires that are happening somewhere in the West, and the smoke that fills our valleys seemingly every summer now are a real health threat. And those sorts of things. Oh, and then we also have floods in Montana. This I don't know if you've seen this, but this was put out by Yellowstone for the floods that happened this last year. Well, I think you get the picture. So that was a 1 in 500 or 1 in 1,000 year flood. I mean, our ability to predict those extreme floods is really poor. Nonetheless, they're the sorts of things that one would expect with climate change, a real slow moving storm with a lot of snowpack. It's a rain on storm event. These things are described locally in a few documents. So the Montana Climate Assessment came out in 2017. That was followed by a report on climate change and human health. And most recently, we did an assessment of the Greater Yellowstone Climate Assessment. And all of these are available online. The goal of any assessment is to try to take scientific information and put it into language that hopefully everyone can understand and finds useful. So I recommend that you check out montanaclimate.org or GYC Climate to get these documents. The Montana Climate Assessment's most relevant to this group. It was a couple of years in the making, and it addresses climate change, water, forests, and agriculture across the state. And it was the first climate assessment that's been done for Montana. And there aren't that many for other states as well, so it's kind of special. Now, you know, as a scientist, you always feel like, well, if people would just leave me alone, I could sit down and write a damn assessment. But that's not the way these assessments work. They really have to be partnerships to be successful. And so the Montana Climate Assessment involved both universities, the Climate Office, federal agencies, state agencies, the tribes, nonprofits, and even some businesses. So, you know, we had to get all of those people together talking about climate change and what it meant for their particular area of expertise in their sector, and they all contributed to the writing of it. So one question I get as a paleoclimate person is, how does current climate change sort of stack up against what we've seen in the past and in the geological past? Is what we're seeing now unprecedented? And let me give you some sort of yes and no answers for that. First of all, we know that we've experienced ice ages and periods that are not ice ages like now, glacial periods, or what we call interglacial periods. And those have gone on for the last 2 million years or so, affecting Montana. It doesn't take that much cooling to move Montana into an ice age. You might be surprised, it's only 8 to 9 degrees Fahrenheit cooling to make a place like Yellowstone look like this. So to go from this picture to, you know, a non-glaciated picture is not very much cooling, or to go from Montana being half covered by ice sheets to its present state. So the climate system, even in Montana, is very, very sensitive to changes in temperature. If we look at fire records, so here's a paper that came out 2 years ago now, I guess. This is present day, 2005, I think it is, back to zero, the year zero. And this is based on charcoal data like I study. And here's the fire activity for the forests in the Northern Rockies. And you can see that in the last decade, these records show that there's just this astronomical increase in wildfires across the West. And they seem to track temperature as we know it over this time period. So you get more fires during this warm period that we call the medieval climate period, or the medieval climate anomaly. And we've gotten fewer fires, maybe a little bit during the Little Ice Age. But certainly now we're getting way more fire activity than we've seen over the last 2,000 years. So we're unprecedented in terms of fires for quite a long time. This is a reconstruction of temperature based on pollen data for North America. And it goes from present day back to 11,000 years. So it's kind of the end of the Ice Age. So you can see so here's the average temperature of the last 11,000 years. And so the temperatures are either colder or they're warmer. So you can see this warming at the end of the last Ice Age that caused the glaciers to melt and the trees and wildlife to move in. That's very rapid, pronounced warming on a geologic timescale. And then the last 7,000 years, we've gotten steadily colder. The trouble is here's the average for 2007 to 2016 in terms of temperature. It's way above the 11,000 year temperature average. And here's 2016 itself, which is 99.4% higher than the reconstructed temperature values of the last 11,000 years. So I'm looking at the last, since the last Ice Age, we're really experiencing warmer temperatures than we've seen over that time period. And then when people talk about climate change, they refer to the ice cores that are taken in Antarctica, because that's where we get the records of the composition of the atmosphere, how much CO2 is in the atmosphere, and how has that changed. So that's, it's the air bubbles and the ice cores that trap, the air bubbles trap the composition of the atmosphere at that time. And the ice cores right now go back 800,000 years. And what you see in the blue line is the levels of CO2 measured in parts per million, and the red line is the temperature as it's measured around Antarctica. So it's not a global temperature, it's an Antarctic temperature. And you can see that there's times when temperature and CO2 are high. These are called the interglacial periods. And then when it's low, it's the glacial periods. And we've had 1, 2, 3, 4, 5, 6, 7, 8 interglacial periods before the present interglacial. And you can see that the levels of CO2 really sort of go up and down within this envelope of variability. They kind of stay pretty much in the same range. Here we are today, but right now we have 415 parts per million of CO2 in the atmosphere. We're way up here. So we're unprecedented in terms of the last 800,000 years as well, in terms of levels of CO2. Now, as a geologist, I say, well, when's the last time we've had 415 parts per million in the atmosphere? You have to go back 3.3 million years ago. So this is what Montana looked like 3.3 million years ago, when the atmosphere had the same levels of CO2 that we have today. Not a bad place, maybe, but it was 10 to 15 degrees Fahrenheit warmer. Sea level was, because it was warmer, there were no ice sheets in the north, in Greenland or Antarctica. They were all melted. And so sea level was about 25 meters higher. It was a very hot and humid place. So that's what Montana, would be like if we were fully in equilibrium with the CO2 levels that we have even today. Another interesting thing about past climate change is there's been times that have been so dry that Old Faithful stopped erupting. So it turns out there was a mega drought between 1233 and 1362 AD. And it was so dry that the eruptions stopped happening at Old Faithful, and trees actually grew on this cone. So there's fossilized wood that's buried today on this cone. And when they look at the tree ring records, they can estimate when those trees were able to grow on the cone, and they can line it up with a well-known drought in 1233 to 1362. I suspect that during the medieval period, there were other droughts when this was also the case, but this one was published a couple of years ago, and that's pretty interesting study. A lot of people compare what's happening now to the Dust Bowl. So the Dust Bowl in the 30s is shown in these graphs with a yellow box. So this is the temperature of the Dust Bowl, and here's the drought severity as measured by the Palmer Drought Severity Index versus present day. And what you can see is that the Dust Bowl had some really warm years, like I think 1934 was a super warm year, 1931. But in general, the trend is shown by the blue line is that we've gotten consistently warmer since the Dust Bowl. So on average, right now, we're way warmer than the average temperature of the Dust Bowl. On the other hand, the Dust Bowl was a very dry period that lasted for several years. It was a period of annual drought. And if you look at the blue line here, which is the average, you can see that we are not as dry. In fact, we're not nearly as dry as the Dust Bowl. So in terms of temperature, we're warmer, but not in terms of experiencing this sort of mega drought of the Dust Bowl. So I'm moving forward towards more recent in time, just to give you some information here. One thing is that when you look at the temperature data for the 20th century, 21st century, it's gotten significantly warmer, especially since 1950. It's gotten about 2.8 degrees Fahrenheit warmer. This is for central Montana that I grabbed this data. So here's the Dust Bowl years here, but you can see that we've had this sustained period of warmer temperatures starting in about the mid-1970s. And there's some ups and downs, but on average, we're definitely above the normal and we're getting warmer. You can also look at snowpack. Snowpack is measured right now, April 1st. So it's, it's what's available what's accumulated and measured on April 1st. And since 1950, the red circles show you the entire Western US. There's been this really dramatic loss of snowpack in the West, shown by the red circles. There's a few blue circles where it's increased, but generally we've lost about 20 to 80% of the snowpack that we used to get in 1950. And the big thing that makes us different than the Dust Bowl is it's not that we're experiencing annual drought, it's the season of precipitation has been changing. So here's 1950, here's the average since 1950. And what we're seeing now is that we're getting less precipitation in winter and summer and more precipitation in spring and fall. So that's not the Dust Bowl. The Dust Bowl is year-round drought. This is a change in the season of precipitation that we're experiencing now. And I think just listening to you all and your observations, I think you probably would agree with this image. And since 2000, here's the drought monitor data. So here's 2000, here's 2023, and these bars are the droughts. You can see that we've had 2 prolonged droughts in central Montana. This one that started in 2000 and went to, depending on how you want to cut it off, 2008, is called the turn of the century drought. It's actually got a name now. And it was very, very prolonged and had some years where there was exceptional drought. The one that we're experiencing now, and it's not clear where it's going in the future, is more intense, hasn't lasted as long yet, but I know that's a matter of concern. So we are experiencing droughts. People that look at the turn of the century drought say it's the most intense drought in the Missouri River Basin in the last 800 years. So just to summarize all of that information, our recent temperatures are as high or higher than any period since the last ice age. So I just picked the last 20,000 years. Our drought is not as severe as other droughts in the past, probably, but the jury's not in on that. And that the CO2 levels in our atmosphere now are higher than any period that we've had since the Pliocene, which is 3.3 million years ago. And then in terms of what's happened recently, and in many of your lifetimes and mine, there's been significant warming, 2.8 degrees Fahrenheit. There's been a lot less snowfall, especially at low elevations. The snow just doesn't accumulate below 8,000 feet as it used to. We're seeing earlier snow melt and earlier runoff. The season of precipitation is changing, and these 21st century droughts are starting to last multiple years. So when climate scientists look to the future, what they do is they have these scenarios of how the future might play out. And these are called RCPs. And what they're doing is they're developing sort of plausible scenarios of how CO2 might increase given the way society and politics and energy development and technology are going to develop. The most extreme scenario, RCP 8.5, is where we're sort of just keep on the trajectory that we've been on, and there's not much reduction in greenhouse gases. So that results in a high amount of CO2 in the atmosphere by the end of the century. Internationally, we're trying to, flatten this curve, but probably I think we're on this scenario where we're going to increase to the middle of the century, and then we'll figure it out and things will stabilize. We'll stabilize the amount of CO2 in the atmosphere. So RCP 8.5 is kind of an extreme case, and 4.5 involves some effort on our part to stabilize the climate. And those are the 2 scenarios that we use in the Montana climate assessment. Those scenarios, what happens is those scenarios get run in into global climate models. These are done around the world. There's about 20 really labs that have developed global climate models. They're very complicated. They incorporate all kinds of aspects of the climate system, you know, different layers of the ocean, different layers of the atmosphere, human influences, land surface, and so on. They're really complicated. They take an extraordinary amount of computer time. Those results come out and they're very coarse. So this is the way most GCMs, global circulation models, would see our region. Not very helpful because we have such complicated topography and weather. And so those results get downscaled or put into different set of models that interpolate it to a sort of finer resolution, grid. Now, sometimes those high resolution results get aggregated to a county level or aggregated to a climate division level, or sometimes they're just looked at as they are. So that's how you do the future. You start out with a scenario, you put it through a model, and then you downscale it. Here's Petroleum County coming from a USGS summary of those models. Here's the historical trends from 1950 to about 2005. The historical data then overlap with the models. And here's that extreme scenario, and here's the stabilization scenario. The cloud, the pink and the light blue shading show you that there's a lot of overlap in these models as to what they project for the future. But the lines themselves are the median of those results. At the end of the century, RCP 8.5 has Petroleum County about 10 degrees warmer than it is in this period. And RCP 4.5 has us about 5 to 6 degrees Fahrenheit warmer. Notice no matter what scenario we take, we're on this sort of warming path all the way to the middle of the century. And then only in the last part of the 21st century do you really see the consequences of those different scenarios. So this is from the Montana Climate Assessment. Here's 4.5, here's 8.5, and 8.5 always looks worse than 4.5. So here's the middle of the century when hopefully we'll all be alive and doing well. A 4.5 degree Fahrenheit increase for Montana. In this scenario, a 6 degree Fahrenheit increase for the extreme scenario. And the models show complete agreement. All of those 20 models provide the same results. So this is a very robust finding for the future. And here we are looking at different regions in Montana. So we are in the central region for this meeting, and the intensity is showing you the level of warming for 4.5 and 8.5. We get warmer all year round. We get warmer in the winter and we get warmer in the summer. So that means hotter days in the summer and less freezing in the winter. So these rising temperatures are going to make drought worse. That's a very robust result. It's going to increase the number of days over 90 degrees by maybe as much as a month by the middle of the century. Precip, the trends in precip, annual precip actually increases in the model, but what changes again is the seasonality becomes more extreme in precip. So blue is where the months of the year where it's going to get wetter, and yellow, the yellows are where it's getting drier. And you can see that there's increases in precipitation in winter, spring, and fall. There's pretty high model agreement with that. Models have a harder time doing precip than they do temperature, so the agreement isn't as high. But you can see it gets wetter in the spring on that trend that we've already seen, and it gets drier in the summer. This is again a mid-century result. The big change for me is the snow to rain transition. So this is the stabilization scenario, and the green, so here's the end of the century, here's 1950, and the green is the elevation of rain, where rain is dominant. The blue is the elevation where snow is dominant, and the red, orange, and yellow are the elevations where we get that rain, snow, slush that we all kind of hate. And what you can see is that this is for the Yellowstone region. In 1950, that snow was dominant down to 7,000 feet, but elevation's been slowly rising so that by the end of the century, it's going to be at about 9,000, 10,000 feet. That's simply because it's getting warmer, right? So the snow, likelihood of precipitation falling as snow becomes less and less, and we're more likely to get rain-snow mix or rain. And you can see that in the map. So here's the greater Yellowstone region. Here's the snow cover in blue in 1990. Here it is in 2030, 2050, 2070, and this is the end of the century. Simply because it's getting warmer, we are losing our snowpack. And you can see that in snow-dominated rivers. So this comes from the Montana Climate Assessment. Here's the Clark's Fork. What happens is it gets warmer, is you get faster runoff, you get more rain on snow events, and then you go into summer with decreased flow. And decreased flow is warmer temperatures, less available water. The projected flows come about 15 to 25 days earlier by the middle of the century in this projection. So just to summarize, for central Montana, 4 to 6 degrees Fahrenheit by mid-century, maybe 10 or 11 degrees by the end of the century. More precipitation as rain instead of snow. Snow and runoff earlier in spring, water shortages in summer, and more days of extreme heat and less days of freezing or below freezing. So what do we do about this? There's two things we have to do in the society and in Montana and as individuals. The first thing we have to do is flatten the curve, right? We have to reduce our emission of greenhouse gases so that we're not on the red line and that we can, as soon as possible, flatten that curve. You know, it's interesting. When I look at this graph, I see my own life. Here's the black curve is the period of time when my parents lived, and they didn't see much climate change, and they didn't think it was really a very big issue for them. I'm on the part, you know, being born in the 1950s, I'm going to live to 2050. No matter what I do, I'm going to see warming, according to the model projections. It's warming now, and even if we reduce greenhouse gases, we're going to see warming pretty much to the mid-century. The person I worry about is my granddaughter, who's going to live her life the last half of the century, and she's going to see so much change at a rate I can't even imagine. And, you know, I wonder if she's even going to recognize the places in Montana that I know and love and explore in her lifetime, given all the changes that are going to occur. This isn't a crime story. Climate change is not a crime story. We know the causes of these greenhouse gases. We know where they come from. In the US, most of them come from transportation and electrical power, but a significant portion from industry, commercial and residential, and agriculture. And there's a long list of things that we can do in each of these sectors to reduce greenhouse gases. Some of them are in our capacity to do now, and some of them require rollout of new technologies. But we, you know, I think most of us are pretty optimistic that we can reach some sort of net carbon neutrality by the middle of the century if we all put our minds to it. The other thing that we have to do in Montana is plan for change, because, as I said, change is coming no matter what happens, because of the sort of residence time of greenhouse gases in the system. So we need to be ready to live with heat and drought and floods like we had in 2011. We need to plan for ecological change. We can see that happening already. And the paleo record that I study indicates that anytime the climate's changed in the past, the ecosystem adjusts. So we're seeing grizzly bears on the move. We're seeing the decline of whitebark pine. Toads and frogs are having a hard time. Migratory animals arrive before food sources are available. Cold water fisheries are having a hard time as those cold water fish are being pushed higher and higher in the system. And then, of course, there's this increase in non-native invasives that we heard about this morning. These species are, in many respects, well adapted to climate change. So ecological change is going to happen, and it's part of our future. We also need to learn to live with wildfire. The paleo record tells us anytime it's gotten warmer in the past, we've had more fires. And, you know, so we need to be ready for that. Fires are really part of our future. And I think the big thing is we need to plan for uncertainty, because think about it. The temperatures are getting warmer. There's going to be less snow, more rain. The snow is going to melt sooner. We're going to go into summers being dry. That puts a lot of stress on communities and people in agriculture who depend on reliable sources of water at the end of the summer. It puts stress on us thinking about the possibility of extreme weather events and fire. We need to be ensuring that our infrastructure is ready for these extreme events. There's health risks ahead that we need to be aware of that are related to heat and smoke and insect and water transmitted diseases, the mental health consequences of climate change, the fetal and maternal impacts of warmer temperatures. And the most vulnerable populations in Montana are people who have already have health issues, the old and the very young, people who live far from services, and people who live in poverty. And we need to be sure that as we plan for climate change, we don't leave these vulnerable sectors of the population behind. So I'm sort of in the climate assessment game. You know, I've done 3 climate assessments for Montana because I really believe that people need information as local a scale as we can possibly give it to them. And I was involved in a climate solutions plan for Montana. These things are all available online, and I hope that people will use them. I've also been around the state talking to people about climate change because I think that's one of the things that we need to do. So I've been in roundtables and meetings and at rallies, and I've been out with tribes looking at plants that are of concern to them. I've talked to teachers and students, nursing homes. I will go anywhere to talk about climate change because I think that we need to really talk about this very serious issue and not overlook it. I just dug up this graph today, and I think you might be interested in it. Yale University does a survey of attitudes about climate change. And so this was a question that they asked the nation, how many people, adults, think global warming is happening? And here's Petroleum County. And it's interesting. So 67% of the people in Petroleum County think global warming is happening. And that's about the same percentage as in Montana. It's a little bit less than the country as a whole, but that percentage has been going up steadily. People understand global warming and they know it's happening and they're becoming more and more aware of it. So that's really positive. On the other hand, the survey asks, how many adults think global warming will affect them personally? And I think this is where we're failing, where we're not talking about it enough. You know, in Petroleum County, 53% think it won't affect them, little or not at all. That's about the same percentage as Montana. And it's really not that far from the US as a whole. So, you know, we've done a good job of selling climate change as something that's happening in the Arctic and affecting polar bears or affecting people along coastlines. But we haven't done a good job of explaining to us in Montana that this is going to have an impact on us personally, you know, and that's the conversation that needs to happen. In the Yellowstone assessment, we interviewed people around the greater Yellowstone ecosystem about what their concerns were about climate change. So these were ranchers and farmers and people in agencies, people in NGOs. We asked them, what did they observe? What information do they use? You know, what projects are underway and so on. And I think the results are not so different than what I heard here. Most people in Montana are very concerned about water. I think water really stands out as the big issue that people think about and worry about. There's other topics as well. A lot of them are sort of tied indirectly to water, as you can see. But water is a big thing that I think we could all be united behind. And in fact, I love one of the people that were interviewed in the upper Yellowstone watershed said, more information and data is a big need. The awareness of climate change is already there, but we need more information and tools in the toolbox. And I think that's true for most of the state. We really need to get the information and make it available to people in a timely way and in a way that's both useful and usable. So thank you. I think that's all I have.